Now I'd like to look at how to implement a queue using an array for item storage rather than a linked list. Now this is quite a bit more complex, but it's worth understanding. When we allocate the queue, the backing store is an empty array with 5 slots. Now as items are enqueued, they're added to the array from the front to the end. Now at this point, the queue has 5 items in it, and the array is full. So if DQ were called, the first item would be removed. This has opened up a slot in the array. A second call to DQ would free another slot. And what happens if we call InQ again? Well, the value is added to the first open slot. Now we have a queue whose array has 4 of 5 slots filled. The head item is the third item. That is, it's the next item that will be returned when DQ is called. The tail item is the first array item. That is the last item in the queue. There's also an open slot in the array. That slot will be filled the next time InQ is called. So the question now, with the array being full, is what should happen if InQ is called yet again? Should an exception be thrown? Or should the array grow to accommodate more items? Well, let's take a look at the case where we choose to grow the array. The first thing we'll need to do is allocate a longer array. Now this array is twice as long as the original array. Next, we'll need to copy the items from the head pointer of the queue to the end of the existing array. Now this copies items 3, 4, and 5. Notice I said the head pointer of the queue to the end of the array. Now unless the head pointer was at index 0, we haven't yet copied everything. So now we need to copy everything from index 0 of the array up to the head pointer -1. It's the head -1 because we already copied the head value. So we copied 3, 4, 5, and then wrapped around and copied 6, 7. And you can see our new array contains the values 3, 4, 5, 6, 7. Now this array now becomes the backing store for the queue. And the head and tail pointers are updated to their new respective indexes. So as you can see, array growth is quite a bit more complex. It requires memory allocations, and it requires copying data around in a non-trivial manner. But the performance benefits of using an array, as they were with a stack, are somewhat significant. All the items are kept together closer in memory. The allocations are reduced to periods where the array is growing. And inqueuing or dequeuing items from the queue requires only setting an array value and modifying some indexes. So let's go to Visual Studio and take a look at a queue implemented using an array as the backing store.